Hi everyone, my name is Nelson, team leader of the project Stock Forecasting App, and I am going to go through the demo of the project today. Follow up is our schedule throughout the 20 minutes demo we're going to present just now. We are going to go through the introduction, the app demo, where we have the front end demo, and the back end demo through the Jupyter notebook which we wrote with Python, and a conclusion of what we've done so far prior to it. So starting with the front end demo, I'm going to log in directly through my remote desktop where all the tools are found. Okay, there we go. So here is the app already starting, but I want to start from scratch for us to see how it goes right from start of the project. Stock Forecasting App is the name of the project. This one, yes. So I'm going to build everything. As we can see, these are all the classes. We do have the login activity, login error, login success, main activity, registration activity, the stock data, the user model to register users, and the welcome page. All of these classes have their corresponding XML layout, which constitutes the activity. So after building is complete, I can directly go on to run the app. As previously said in the PowerPoint, for instance, this is what is going in the background. So here is our app. The app comes up and displays directly a graph of the stock price for Microsoft data. We have the home, we have a login button, and we have a welcome with no name. We have a spinner which displays the different type of stocks we do predict the price for. We have the Microsoft stock, the Google stock, and the Apple stock. Currently we strictly working on the Microsoft stock because after this is done, then everything can be applied for both the Google and the Apple stock. So currently we have the Microsoft stock on graph view interface. This interface is quite interactive, and we are going to come up with pretty much more interactions in the very few times to come before the end of the final project. So from this we can, for instance, zoom in. Yes, here we do zoom in if you want to study the graph close enough. And in this graph, our vertical axis constitutes the price, which is in dollars. It ranges at this moment from $133 to $137, and the x-axis consists of the time. So this time ranges from 5-minute intervals. This is a time layout of 2 days. 5-minute intervals is the daily rate we get to predict the price for. We choose minute basis because the price of the stock here, Microsoft for instance, is really fluctuating, and having such a rate will help us capture the best features to make further predictions. There are various ways we could have a rating. We could have it daily, we could have it monthly, we could have it even hourly, but we decided to take it minute by minute in 5-minute interval because that is when we capture the best changes and can make preferred predictions. So again, we can drag it up and down and reach at the end. And the device is much more fluid compared to the Android emulator. So we can zoom back to our original graph and have a feel of what it looks like completely. So here we can see that the maximum price is it went at 132 and 38, and the minimum price went as low as 132. Now I am just going to predict the next price for 1:30 p.m. So at 1:30 p.m. what is the price going to be? It should be something. Okay, the price is $131. So at 1:30 p.m. we predict the price of Microsoft stock to be $131, and that makes sense because here we are already down to 132. So maybe it can still go down. So our predicting curve will show something of 131 in 1:30 p.m. whereas now we still are at 12:49 p.m., which makes sense. This layout is going to show a label of the predicted and the current. Here is the current stock prices. So we're going to go and see what is happening in the back end to know exactly what is going on. That said, we have a home button. As a user comes in, he can have this view as first hand, and he can go and log in through the home where we have the welcome page, and we can directly create a user. For simplicity reason, we can just create the user CS7455 test user, for instance, and yes, we can go with CS7455. Oh, let me just say yes, CS7455 6 at ksu.edu is the email, and the password 123456. So this is a potential user we're creating, and when we register a user, it goes directly to login. So to log in, I'll log in with the same email, which is CS7455 6 at ksu.edu, and the password is 123456, I believe so. Then we can log in. Login failed, so there's surely a problem with the login. Let me log in again. Email CS7455 at ksu.edu 123456. Login. Okay, good. The login is successful this time. Oh, it was the second round. I was already worried. So this is welcome username, whereas before we just had the welcome button, which shows a little level of personalization towards us recognizing our new user who just registered. And yes, that is it about the login. Again, if you are already a user, you don't necessarily need to come back to the welcome to the welcome homepage. You can directly log in, like as we cancel welcome, we can directly go to the login and log in as a CS7455 at ksu.edu 123456. There we go. Yes, now welcome username. So this is what the preview of what we did so far looks like, and yes, we look forward to having it for Google and for Apple stock. We look forward to adding a push notification, and we also look forward to coming up with a phone vibration. Apart from that, what we can add again to make this more interactive, apart from the zoom we have here already, is to make sure that when we come with the mouse on touched, like when we touched with the mouse here, it should pop up the corresponding Y price and the X date. This will help the user know exactly what is going at this point, or at this point, or at this point in the graph, to be able to make a bet or to be able to make a prediction prior to the next price. This is what the front end looks like. So now let's go to the back end. Moving to the back end, everything was done on a Jupyter notebook. I'm going to present it on a Jupyter notebook because I believe it's much more interactive for presentations. Let me open the Jupyter notebook. There we go. So here is what the back-end processes look like. I'm just going to go through a 10 minutes of what we did in the back-end. So to start, this tutorial is to predict the future price of a stock using real-time data from a stock through available APIs. So because we will be working with sequence of arbitrary length, we will be using recurrent neural network. Again, in our previous post, we talked about using various machine learning models to make predictions. And in this model, we use recurrent neural network because we found it to be most appropriate for time series forecasting and for our case. Before this, we used support vector machines. It did give good predictions, but not as well as a recurrent neural network in terms of the loss or the accuracy of how best they predict. So in this tutorial, we should definitely be familiar with Keras TensorFlow tutorials and basic recurrent neural network explained in this tutorial. The dataset, we collect dataset from AlphaVantage API. It is composed of a tiny knitted community of engineers because and business professionals with leading providing APIs for real-time historical stock forecasting. So this is actually the API key we collect from the AlphaVantage website. So from this API key, for instance, we do a post and request. We do follow the post and the do post and do get request format provided by the Java and HTTP connection request interface, and that is where the networking module of our mobile device comes into place to actively make predictions in real time. After every 5 minutes, our dataset is updated and our graph view is updated. So this API has a query where we have a function time series intraday. So it gives a time series daily of Microsoft, and it gives it in 5 minute intervals. So this is the 5 minutes intervals we do have, and to have this you need to be registered as a user and have an API key, and this is the demo version. So our API key is demo. The output size is full. We want a full data set because the recurrent neural network needs a lot of data for training. So if I just attempt to click on this, it is going to bring me to a sample JSON file of what our data set looks like. Okay, let's do this real quick and just have a look of what the JSON is like. Okay, got it. So this is what our dataset looks like. I just had some issues with the API key here because the previous API application programming interface given the previous link needed an API key, but I don't have the API key of it, so I need a demo version. That is why I have this version of the dataset here. So sure, we have the metadata, we have the information intraday for 5 minutes, and we have it in the form of open, high, low, and close, and volume prices. And all of this gives a time series after every 5 minutes. For instance, we have the one of today, 2019, the 7th at 12:55. Now it is 12:59. So 5 minutes. This is the most recent one that just came up. And after we have the one for 12:50, then later the one for 12:45, then later the one for 12:40. This is for just today, July 3rd. And given that it's a short version of the demo, it's not everything, so it will probably go right up to July 2nd. Yes, yesterday. So this is the data for today and yesterday. That is what the data looks like, and that is what Alpha Vantage offers to us. That is what we're going to use to train our data, our machine learning model. The flowchart here. In this tutorial, we are trying to predict the next stock of the the next price of Microsoft stocks in 5 minutes interval, given the current, past, open, close, high, and low stock prices. We use a recurrent neural network, again already said, because it works on sequences of arbitrary length. During training, we will use a total of 1,344 data points for 2 days, containing all the features we just mentioned, which is the open, high, and low stock prices. To start off, we do go through our library imports. This is just Python, so I'm just going to scroll over everything because it is not the main aspect in our mobile development class. We initialize our model, a sequential model. We have the input, the dense, and the get recurrent unit. We have the embedding. We have the loss function, which is the RMS prop. We also have early stopping, and we have the model checkpoints TensorBoard. So this is the most important here, because this is what will help us save our model and save the checkpoint, then freeze the model to deploy on the mobile development software. Android Studio. We use Python 3.6, and these are all the versions of the various libraries we do use. Loading our data, we just load our data using pandas, because we want to work with Python and build our model with Python. So here's the stock, and here's the CSV, and here's the intraday 5 minutes full CSV file. Here is a head of 5 samples we're talking about. So if I just want to renew everything and just make sure I have the most recent data. So yes, today, this was for some other date. This was for some other date. Yes. Oh, this is for some past date, because it is training data, and training data is previously accumulated data for few months ago, and this happens to be on the 28th of June. Now we need to declare our target name. Our target name is the open price. So the open price is what we are predicting for. Then later on, we will need to go through the stock index. The stock index are the dates. We need the stock index to be able to have our X variables for predictions. We have the stock value, and here this is the shape of what our data set looks like. Now we go through the adding data. We add some input signals and data that may help our model and make predictions. That is what makes predictions for us. Then we have the target data for predictions. The target data is the open price, is what we are predicting for. Given these dates from the index, we want to predict the price of each date after every 5 minutes. So after having the target for prediction declared and defined. We now define how we want to shift the time format. So this is the shift in minutes after every 5 minutes, and this is the shift step. So after every sample we add a 5 constant, letting it designate the 5-minute difference. Here's the stock targets which we are appending to our stock data, and here is just a tail showing how we went up by 5 minutes. So the last 5 samples of our data set is going to have none because we kind of had a shift upward by 5 minutes. So we use NumPy array to train our data sets. So here is our X data because we want to convert the pandas data frame to X and Y variables. Our X data is now split into a training and testing data set. So this is the length of our data we are trying to get, and we have 1,165 samples. Our split threshold is 0.9, so 90% is used for training and 10% is used for testing and inference to know our model is working good before deploying it on mobile. These are the input signals, these are the output signals, these are the number of input signals, these are the number of output signals, and this is where we scale our data. We need to scale our data between 0 and 1 because this will help us avoid overfitting, or it will also help us avoid variance. So this is what everything looks like thus far. This is the data generator. We generate data to fit into one model. So let's go just straight forward to the model. So before going to the model, this is what the stock price looks like in a raw format. After having it displayed in a raw format, this is what the signals of the prices looks like also in the raw format. After displaying all that, we go to our validation set and we perform the same thing. Now we create the recurrent neural network. To create the recurrent neural network, we have a model which we need to instantiate and give it a name, sequential model. Then we add one layer, which is the get recurrent of 512 units, and we have an input shape, which is the number of signals we had declared before. After that, we add another input layer or another internal layer. So this layer is a hidden layer. Actually, it has this. It moves from the 512 units to the number of units from the output layer, and it has a sigmoid function as activation. Apart from that, we now go through adding the last layer. The last layer is composed of just one output node, which will be our prediction prices. Now we go through the loss function. It's good to know about the warm-up steps. The warm-up steps is what helps us train the neural network for it to be confident enough before making predictions or before going through training. And we define our warm-up step here to be 20. The loss just uses the RMS prop loss function from the Keras model through TensorFlow. After defining all those components of our model, we now define the optimizer. The optimizer with learning rate of 1 to the -3, and we compile the model with the optimizer. Here's the model summary: a get recurrent unit, one dense layer, and the number of parameters. We do have callbacks to checkpoint our model training after each and every 7 epochs. And now we train the recurrent neural network. This is us fitting for 20 epochs and for 50 samples through each epoch with a validation dataset and with the callbacks to save our model and monitor the learning rate, how it learns. So in this neural network model, we train and make sure the loss is reduced. After every 3 times, we update our weights with the previous weights to train and have the loss reduced again. So during 3 epochs consecutively, if the loss does not reduce, then we stop and save the model weights at that point, because that should be where the loss has kept a constant uh, a constant value and can't reduce any further. That is why here our loss is 0.081. For instance, here the loss is 0.071, which has reduced. It is reducing here again. Here it is reducing, but from 0.003 it stays constant. First time, second pass, third pass, it stays almost constant still. Here it just went down to 0.028, and here it's still back to what it was. So here we just realize that the loss is at its lowest and it can't reduce any longer, so we don't definitely need to go right down to 100 epochs or more. Loading the checkpoints. So having our model trained here with a loss as low as 0.030, then we are confident enough that our model can make good predictions compared to training. But we use the validation data set to make sure we don't overfit. We want to enable our model learn on new testing data. And again, before training this model, our data set was split into 2 sets, training and testing, to make sure we don't overfit. Loading our checkpoint. Here is where we load our checkpoint to make sure we have the best and most recent checkpoint. Then we load the weights of the Keras checkpoint, and we evaluate our model. Here's the evaluation done on test data, and the evaluation done on test data gives a loss of 0.087, which is pretty much a good number. So if we see during our training, here was the loss on training and validation data, and during our testing, here is still the loss, 0.008, which is a confident reason why our model shouldn't overfit and should work good on our mobile device. That is it, and this is what our output looks like. This is the white test result, and these are the prices. The prices ranges from $131 to $133. Yes, $133. That makes sense from the graph we just saw in our demo. And this is just plotting. This is what our results looks like prior to the predicted value and the actual value. The predicted value is what is in orange, and the actual value is what is in blue. Here is a very good example where we follow another training set and we try to zoom out and increase the number of samples with the day. Still, it maintains the same price range between 133 and 138, and we see that our predicted model in orange actually lags almost same with the actual model in blue. And we need to note here how the price does not oscillate very much every 5 minutes. The open price normally oscillates within each day. This is what our stock open price looks like, and this is what the stock predicted price looks like. This is what our loss function is at the moment, but again we look forward to improving the loss function for it to be as much as close to the true as possible, something like this. So that said, this is what we want to have on mobile. We want to have the predicted value in orange, which is what we're going to integrate, and the actual value in blue. Again, something like this, where this is the blue value and the predicted value will be lagging through in orange. This gives confidence to our users that we have accurate models, and when we make predictions, they are able to be certain of having good prices. We just went through the backend demo with Jupyter Notebook and Python. Now we can conclude. So to conclude, this project uses a neural network to predict several time series from a number of input signals. We use real-time Microsoft stock data through API to predict the next stock price every 5 minutes. It worked reasonably well for predicting the open price, where the daily oscillations were predicted well, but the peaks were sometimes not predicted so accurately. You can use this method with different time series, but you should be careful to distinguish between causation and correlation in the data. The neural network may easily discover patterns in the data and are only temporary correlations which do not generalize well with unseen data. You should set input and output data where a causal relationship probably exists. You should have a lot of data available for training, and you should try and reduce the risk of overfitting the model and training the data. Using early stopping as well as we did in this tutorial is a good example, and also splitting the dataset into training and validation. So that said, when we have this model frozen, I just want to make sure we understand where it was saved and how it interacted with the mobile device. We had to create an asset, and in that asset we had to load our model. Here is the name of the model: Optimized Frozen Linear Regression Model. This model is what is loaded using TensorFlow Lite into our Android device in the main class. So in this main class, let me expand it more for us to see. Can I zoom in? I'm not sure. So in this class, I declare a private final string model name having the link to the model in the asset I just showed. And apart from that, we also declare a private TensorFlow inference interface for inferencing. And when we do that, here is where we instantiate our TensorFlow model for inferencing, and here is where we perform inference. So here is the input we get when we pass the float from the input text, get text, the date we get, which we showed during the demo, and here is where we convert that into a string. Then when we convert that, we directly set the test from the result gotten from the performed inference. The performed inference is a function which is performed in an external module. It's an external function performed. Let me get to the performed inference. Okay, here is our public private method, because we're going to use it just here in the main activity, perform inference. And in this private method, we feed our input node an input shape from the model we trained. After feeding that, we run the model onto a new string through the output node we received from that model. Then after running this, we definitely have the results, which we instantiate as a float. Then we perform some inference where we fetch the data from the output node of our trained model and we fetch it into results. After doing that, we now return the result value. Again, when we instantiated our TensorFlow model, we had the input node, then we had the float array, and we had the input shape. The input shape is what our model looks like. The input node is what the input data from the user is going to receive, is going to give, and the TensorFlow interface is going to receive that to perform inference. That is what it looks like, and that is where the bottleneck connection between TensorFlow and the Android for mobile stock prediction springs from. Okay, I believe that should be it. Thank you for listening to me and to us, and we look forward to finishing everything prior to the project and completing our modules.